You know, transformers are not great at the time series forecasting. But what if we represent time series like the sequence of tokens? It isn't the new idea, but still. I know that modern deep learning models use some sort of making patches for encoding data. This patchification is made by using Fourier transform and other techniques. It doesn't matter right now. I want to test something simple, but on the hard data. I took the S&P 500 index prices from Kaggle. Each day can be viewed as a directional move with some magnitude. So we can make hyperparameter filters the magnitude of stock prices movement. And we get 4 conditional tokens. Up with small changes, up with big changes, and the corresponding down movement. I took 1% as filter. It's rather high for daily changes, but not so rare and unusual. After that, we obtain the sequence of token describing all the S&P 500 history. And voila! Next step is construct transformer architecture for forecasting next token. I must admit that I humbly took the transformer code from Andrej Karpathy blog video with some cosmetic changes. The link is below. A regular, reliable model from folk. Then I fed data to this tiny LLM. The initial result inspires some confidence. I made some additional experiments. The context window gives good results around 64 digit. Only 8 and 16 embed dimensions ensure networthy results. Higher values simply lead to the data memorization. The quantity of heads seems to have a little effect. The number of transformer block plays a bigger role. We get a parabola with a minimum around 8 blocks. Although it's strange, isn't it? Additional attention mechanism do nothing with this data structure. I experimented a bit more with learning window size. I mean different splits between train and test data. And something scary is happening. If the loss should decrease with increasing available data, but here it is parabolic. Another mystery. As if something happened at the late of 70s and the early 80s. It's clear what happened this time in the economy and finance, but this is not related to our topic and artificial intelligence. But one way or another, learning occurs, and we can talk about some robustness. Investigation is not complete, but I must stop. And now the most interesting part. This is what we got. Can we predict the market later? Even a little. The number of matches is around 35%, and that's better than 25 if the letters were completely random. Another good thing, the generation of the new market letters seems to replicate the distribution of a real market, and that's beautiful. But the result itself is mediocre. The prediction errors are very large. And you know what else is interesting? Simply predicting the same letter that was on the previous step also gives around 35% probability, but with a completely different logic. And the intersection of strategies gives around 38% of correct answers, which is better, but the increase is very small. It's funny. The result is interesting, although not entirely fair. The selection of hyperparameters could be done better. We can play with magnitude or a little bit different architecture or give more and more completely different data. But it doesn't matter right now. But the data ends in 2020. If we want, we can surely test our model on the clean data available till now.